We have started working on A-star algorithm. So far we have implemented open list, closed list, and we have determined the current node. In this lecture, we will get all of the neighbors from the current node. Let's start. Okay, so create here a new method to get all of the neighbors. Let's go just get neighbors, and this method will return a list of nodes, which will be your neighbors of the current node. So up here, just create here list. It will be returning node, and the method name will be get neighbors. Okay, so get neighbors like this. Hopefully, I'm spelling it right, writing it right. Okay, and here we'll get a current node, which you can call node simply. Okay, and here create a new list where we'll be storing all of the neighbors. So list of node, and we'll call it neighbors. Okay, so neighbors, and this will be new list. Okay, so how can we get all of the positions around the node? So if this is a node, or how I will write it like this. Okay, so like this, one more row. Okay, so if this is the active node, how can I get all the nodes around? Let's say the position of the active node is 2, 2. That will be the active node. This is current node equal, it's 2 position. So simply, you need to go now x from here plus 1, here x minus 1, y plus 1, y minus 1 to get here, and you already covered 4 positions, right? And now we need to go diagonally. So how to go diagonally from here? X plus 1, x plus 1, y plus 1. Okay? X minus 1, y plus 1. X plus 1, y minus 1. X minus 1, y minus 1. And that's how you will get from all the positions. So to get all of this, you can prepare simply. I can keep it on the screen so far, because we maybe will need it still. So create here 2 loops simply, okay, where we can cover all the positions like this. For int x equal minus 1, x will be iterating until it's smaller or equal to 1, and we'll increment x plus plus. Similarly, the same thing for y. So for int y equal minus 1, y is smaller or equal to 1, y plus plus. And this way you will get all of the position. And if x is equal to 0 and y is equal to 0, like this, you will simply continue in the iteration because you don't want to cover x and y when it's equal 0, because that's your current node when x and y is equal 0. So if you look at this, and this is your two position. So you will starting with the x minus 1. So the first position here is the x. Well, okay, I will be writing it up here. Okay, so x will be minus 1. So it's first assign the x minus 1, and then y is also minus 1. Minus 1. Okay, so that's your first coordinates where you get. And when you will add it to the current position, so plus, so minus 1 plus 1, 2, 2, this will get you 1, 1. Okay, so minus 1, minus 1, and this will be here 1, 1 position. Now we're going to the next iteration, right? So here you're still iterating, so you will increment y plus plus. This will get you 0. Okay, so the next position will be minus 1. X you didn't iterate yet, only y you're keeping iterating now is 0. Okay, so we have minus 1 and 0. And this should be actually minus 1 and minus 1. It's minus 1 and 0, so this is minus 1 and 0. So we're covering this position now. Then again, you're writing the y plus plus. So now you had a 0, so now you will have a 1. So y will be 1. So now you're going to position minus 1 and 1. And minus 1 and 1 is minus 1 and 1. So minus 1 and 1. Okay? So now you have covered these 3 positions. And now, since you iterated all of the y's, okay, now we've met this condition that y is equal or smaller than 1, you're going to the outer loop, and you're continuing to iterating the x plus 1. So x will become now 0. It was minus 1 before, so x is 0. So you're starting with the x is 0, and again, y minus 1. So 0 and minus 1. Okay, so this will cover you here 0 and -1. Okay, because you are not moving at the x, only one y -1. Now the next one, it will be 0 and 0. Okay, this position you're not covering because not moving at all, it means staying at the position. So you don't want to retrieve this as your neighbor because that's your position 0 0. So we are continuing. We're not doing anything with this. Okay, so now we get +1. We get 0 and 1, and this will get you. Oh, actually, I made it the other way around. This should be 0 and 1, and this should be 0 and -1. Okay, so here 0 -1, 0 0, and 0 1. It will cover you this position. Okay, and when you iterate the last time, so now we're again going to the outside loop for last time when the x will be -1, and here y will be -1 as well. So the next position is -1. No, the x is here 1. We are plus. Okay, so here is x is 1, and y is -1. Okay, so this will be getting you x1 -1. So this is here 1 and -1. The next iteration will be 1 and 0, which is the x position, 1 and 0. And the last one will be 1 and 1, which is here 1 right, 1 up. So this is 1, 1. And this way you cover all the positions and the neighbors, you see? These two iterations. Hopefully that makes sense. Okay, now when we have this, excluding the current position, we will be getting our world position. So let's write here int check x. That's your current node left bottom position. So node x position plus x position. So now we're getting the real world position of the neighbor minus your offset. Okay, we need to always apply grid offset x. Okay, and then similarly for the check y, so just rename this for check y. It will be your node y position, the left bottom corner of this position, plus y to get the neighbor position, and minus offset to get the real world position. Okay, so this will get me the relative position to my neighbor from my left bottom position of my current node. And minus this will get me the world position, because we need to always apply the offset to get the real world position. Okay, and now I will just check it for boundaries if the neighbor is not outside of the map. So for example, if we are on the edge of the map and the neighbors would be water tiles, so then we need to check for it. So this you can check like this: if the check x is greater or equal to 0, and check x is smaller than your map width, m_width, and check y is larger or equal to 0, and check y is smaller than height of the map. Okay, then you're safe. This means you're in the boundaries of the map, you're not outside. Then you can get your neighbor. So let's get here var, not var, this var, neighbor. All right, from the grid at the position check x and the check y and the check y. Okay, and also the one thing we need to check for here is if the neighbor is not walkable, we want to continue. So if the neighbor is blocked by something, then we don't want to consider it as a neighbor. So let's write here also if exclamation mark, if the neighbor is not walkable, okay, then continue in the iteration and skip this neighbor. Okay, in any other case, just get your neighbors list and add their neighbor. Okay, and this way you will get all the neighbors, and you can return from here the neighbors. So let's write your return neighbors. Okay, and that's your get neighbors method. Now up here, we have a close list, open list. We can write here some space, and here you can get your neighbor. So just to test it out, let's write here var neighbors. Okay, equal get neighbors from the current node. So get the current node, and we will debug log them out. So the debug log under it, and let's call it neighbors. All right, and this will be your neighbors list here. Okay, let's save it and let's see if we are getting our neighbors correctly. Okay, back to Unity. And let's see. Okay, so let's run the game and we should see every neighbor should be offsetted by 1 position if it's getting correctly. So you can see, yeah, it is. So if you look at this, zoom it. No, I will go to the scene view. Okay, so we are on the -12. This is left bottom position of this node here. It's the -12 and -6, right? That's where we are. And then we are getting the neighbor -12 and -7. So this will be just a y -1 down here. So this is the -12 and -7. That's our first neighbor, you see here. And then -11, -7. So that's the x plus 1. So this will be here, this neighbor. So -11 and -7. This is this tile here. We have this one here. And the last one is -11 and -7. So -6. So this is this one here. Not this one, but just you need to plus 1. So we are going x plus 1 here. So this one here. Okay, and this position here, I don't have space to write it, is -11 and -6. And you can see that we are not considering this side tiles at all. And that's how you are getting your neighbors around. Okay, perfect, this works. If you want to test it out also, you can move your warrior while the game is running. And you'll see here, for example, I'm getting more neighbors when I'm on this tile here. So that's when I'm moving, I'm getting all the neighboring tiles. Okay, but let's stop the game. This will return my warrior on the beginning spot. We are getting all our neighbors. We have verified it. So now we can continue in the next lecture.